Hi friends, very good morning to everyone. So last class we have seen the update process 12C release 2. So we have initiated the upgrade and we have closed the session. So that upgrade has been completed. So now we will see how we can execute the post upgrade scripts. So once the upgrade is completed, your database will be shut down automatically. Then once again you need to connect to uh, database as SDBA and issue the command startup. So I'm just going to do that now. And once we have started the database, we need to execute post upgrade fixup.sql script. So this script will be created in the location where we have given the location in the during the pre-upgrade command. So this is the script which we need to execute. So what this script will do, you can open this with vEditor and you can have a look. But basically, by the output here, you can see it is creating some procedures and it is creating some packages which might be required for the 12C upgrade. Okay, so pre-post upgrade script has been completed. So it says the database version initially was 11.204 and now it has been upgraded to 12.201 and so post dictionary steps or no, there are three particular steps which have been passed automatically. Only thing that have been failed is the old time zone exists which we need to manually fix that. So I will show you that how to fix that manually. So basically the time need to be in sync with what we have in the server and especially the database can be in a different time zone and the users may connect from different time zones. So to have this in place, Oracle will maintain something called a time zone file and we need to upgrade the time zone file to the latest version always, and whenever your database version changes, even this time zone file version will change. So how to fix that, we will see that. But well, before going for that, we need to check the status of the components by executing a post upgrade status script which will be residing in Oracle Home RDBMS admin. The script name is UTLU, which stands for Utility Upgrade 12.2, that is the version which you have upgraded, and the S stands for status. So to check the status and whether all the components have been upgraded properly or not, you are going to execute this script. So now after executing this script, it will give you an output like this. These are all the components that have been upgraded, and for each component how much time Oracle has taken to upgrade. So it has given those details as well. What you need to look at is whether the status here everything is showing as upgraded or not. For example, for any one component it is showing as not upgraded. It means that your upgrade has failed and you need to once again go for a re-upgrade. Means once again you need to follow the steps and upgrade your database. Or sometimes you might see this current status has upgraded, but the version number still may show you 11204. In that case also, you can consider that it has not upgraded properly. But most of the times, if everything goes well, it won't affect the things. But in case if you are seeing any deviation, then you can follow that. And also here it is showing you the things. The total time that has been taken to upgrade the database is 1 hour, 2 minutes and 1 second. And of course, it is also saying that the database time zone is 14, which is older than the current release time. So the current version is 26, but the one which we are having is 14. And how you are going to upgrade, we will see that. So this is to check the status. The next thing is, as I said, we need to fix the invalid objects. So what are all the invalid objects we have, and how we are going to compile them. So we'll see, first we will see what are all the invalid objects we have. So I have taken the invalid object count based on the owner. So each owner, here you can see how many invalid objects they are having, and of course the highest count is with sys schema, because the base tables will get modified, as I said, after during the upgrade process. So you might expect lot many invalid objects here. So that is one query. If you want to see what are all the invalid objects that we have, what are all the type of invalid objects we have, then you can run a similar query. So we have so many invalid objects with views, then followed by synonyms, then packages, then triggers, like this, so many things are there. So to compile all of them in all the schemas in a single shot, we are going to execute this particular script, utlrp.sql. So this, as I said, this is the one which is going to take time, depends on the number of invalid objects. So let us execute that. So meanwhile, we can go ahead and we can see how to upgrade the time zone file. So just a moment. So here I am taking another session in order to upgrade the time zone file. Okay, okay. Actually, the time zone file upgrade requires a database restart, but because I am already executing a script, I cannot go ahead and shut down my database. So let's wait for this to complete. Okay, so here you can see it is saying that it has been completed. Once again, we can execute that select statement and we can see. So now you can see there are no invalid objects. So it is saying no rows selected. So which means all the objects got fixed. Now let us go ahead and update the time zone file. So to update the time zone file, first you need to go ahead and shut down the database and start the database in upgrade mode. So let me do that first. So now the database has been started in upgrade mode. So here we need to execute very small command. So this is the command that we need to execute in order to upgrade the time zone file. So earlier in the output you might have seen that somewhere it is mentioned that the version should be 26 instead of 14. Or well, before going for that, you can also see what is the current version of the time zone file. So we have a view called v dollar time zone underscore file. So here you can see the version is being showing as 14. So to upgrade that, we are going to execute this command. So it is done. Until unless you restart the database, that will not be in effect. So once again I am shutting down the database and then I will start the database normally. So after after the database has been opened, now you can see the time zone has been upgraded to version 26. So just let me include that command as well. So that's it. And then, as I said in the last class, that even we do all these things, still our database even though it has upgraded to 12c, it might not be helpful to use all the 12c features because of the only reason that we have a parameter called compatible. Now here if you see, it is still showing as 11.204, and once your application team has thoroughly tested your application and everything is fine, then you need to go ahead and change this compatible parameter. So once again, you need to shut down and start up the database in order to change that. So that's it, and now we will once again see. So here now you can see the compatible parameter has been updated to the latest one. So that is how we are going to upgrade the 11G database to 12C1. So anyone having questions? Okay, so let's go with the next one, that is the multi-tenant architecture, which is a very new one in 12C. So till now, whatever the architecture that we have seen initially, that was there since from 8i till 11G version. Of course, in 12C also we have that architecture, wherein we have one SGA, and then we have multiple database files. We have two main components like instance and database, all these things. But Oracle has introduced something called one instance and multiple database concept from Oracle 12c version, and it named it as multi-tenant database. Now what exactly is this multi-tenant database? By looking at this diagram you might understand a bit. So there will be a main database into which you can insert some small databases altogether. So if you look at this diagram, we have two main components. One is named as CDB here on the top. So CDB is nothing but container database. Then we have $CDB root. I will come to that later. Then we have something called PDB database. So PDB stands for pluggable database. So what exactly is the difference between this container database and pluggable database is, now Oracle has differentiated all the base tables and metadata of database into a separate database. So like, which means till now whatever the metadata or whatever the base tables are there, it used to be there in the sys schema in the same database. Now what Oracle has done, it has made those base tables to sit in a separate database, and the pluggable database should contain only the user data, which means now you have two databases. One database will have only database metadata and another database will have only user data. So till now what we have is both are there in the same database, but now they both are there in two different databases. Now why Oracle has introduced this? What is the advantage we have? The advantage with this concept is whenever you do patching or upgrade or anything, that will touch only base tables, that will not touch the user data. So because it doesn't touch the user data, and already you are separating your metadata or base tables into a separate database, if at all you want to do a patching, you can do patching only in this container database, and during that process you don't require to touch this pluggable database. So which means there is a improve in the availability. Earlier when we are doing patching, you know that we need to shut down the database and do the things. But now when you are doing the patching, you may not require to shut down the database all the time. I mean for long duration. So that kind of advantages we are going to have with this container and pluggable database concept. And to give a more example on this, I mean a generic example to understand. For example, if you take an apartment complex, so there will be multiple people residing in that particular apartment complex. Like nowadays we are calling it as, I mean some people are calling it as gated communities. So what is there in the gated community? There will be one single building which contains multiple apartments and people start living into it. But for all of them, the base is the apartment building what has been constructed. Similarly, it is the same concept here. Or if you go with another example, you might be seeing some individual houses wherein the owners will be residing in one floor, and they will construct some two or three other floors, and they will give that for rent purpose. Especially here in India you might be seeing that. So let's say like owners are staying in ground floor, and they have another two floors constructed, and they have given that to the tenants. So which means all these families are residing in the same building, but at the same time each one are having their own individuality. Like owners are having their own individual private life, and the tenant who is residing in first floor will have their own private life, and the tenant who is residing in second floor also will have its own life. So here also it is the same concept. So container database will have its own details, and in pluggable database also, as you can see in the diagram, we can have multiple pluggable databases. And the limitation what we have in 12c release 2 is 2000 pluggable databases you can have in one container database. So, and each pluggable database is altogether a different one. Like I'm using one pluggable database, you will be using another pluggable database, What I have in my pluggable database, what I have my data will not be visible to you, or what you have will not be visible to me. So that uh, what we say it as, it is like each individual database again. So this is the concept what Oracle has brought in this multi-tenant architecture. Now, why? What is the reason that Oracle has brought in this? The main reason is Oracle wants to implement this architecture as a database consolidation solution. So, which means if you take in projects, there will be multiple smaller databases as well. Not that every organization or every project will have only bigger databases. They will also have small databases. So instead of having these small databases in multiple servers, if you purchase a high-end efficient machine, like we have some very high-end servers with 1 terabyte of RAM, etc. So if you purchase such kind of hardware machine, and let's say in your organization you have 100 small databases, each of an average size of 50 GB to 60 GB, you can accommodate all these 100 small databases in a single database or in a single machine instead of having them in multiple servers. So this will reduce the cost of the hardware and its maintenance also. So this is the primary reason why Oracle has brought in this multi-tenant architecture. Of course, there is like from the marketing side, if you look at, it is having another idea as well. Like when I talk about this high-end hardware servers, there are so many high-end hardware servers available from different companies. But Oracle, you know that Oracle recently, not recently, many years ago, it has launched something called an Exadata machine, and which it says Exadata machine is one of the super fast servers that they have, or in today's generation what we have. So to promote its Exadata machine, Oracle also has integrated this multi-tenant architecture, because in one Exadata machine there will be petabytes of storage and terabytes of RAM and so many CPUs, etc. will be there. So you can accommodate multiple or hundreds or thousands of small databases into these Exadata machines. So that all this architecture also helped that Exadata thing to be grown. So, so from the marketing point of view, that is Oracle's idea. So is this point clear? Like what is CDB and what is PDB? Anyone having questions?
We can only store the user or application data. Can we store any other data on this, like other users, for
Uh,
example?
Sorry,
uh,
I just found that my system was in mute. Yeah, Hari, can you repeat the question, please?
yeah, sure. Can we store only users or application data in PDB? Can we store any other data also in this,
Other data in the sense?
like temporary tables also that we can create here in the PDB?
Yeah, and anything which is related to user or application data, even if it is a temporary table also, yes, you can store it in PDB.
Mhm.
So now coming to the things, other components what we see here. So you are seeing some one more thing as CDB dollar root. So this CDB dollar root and CDB are one and same. Like CDB dollar root is the main component which is going to hold the base tables. So either you can call it as CDB dollar root or CDB. Both are one and same. And then we have another thing called PDB dollar seed. So PDB dollar seed is the template which we use to create the pluggable database. So for example, I have already two pluggable databases. Now I want to create a third pluggable database. How I am going to create? I am going to create with the help of this PDB dollar seed template. And this PDB dollar seed will always be in read-only mode, only for specific purpose. That too, when Oracle support say, we will be opening that PDB dollar seed database in read-write mode, or otherwise always it will be in read-only mode. So as I said, there are multiple benefits for this. So one is cost reduction, then easy movement of PDB within different CDBs. So this is one more advantage. Like you can have multiple container databases and you can move one pluggable database from one container to another container. So let me show you an example here. So suppose here if you look, let's say this is one CDB. Inside that I have multiple PDBs. And each PDB, let's say for example, is being used by different application teams. Like this PDB 1 is being used by some application 1, and this PDB is being used by application 2. Like that, we have 4 different applications. Now I got some requirement and I need to shut down my container database. So obviously when we shut down the database, all the pluggable databases also will go for shutdown. So what we do, we will go ahead and contact these application teams to have the downtime. Means they need to approve for the downtime. So let's say application 1, application 2 and application 4. These three teams accepted the downtime, but application number 3 has not accepted the downtime. Maybe they are having some important activity or important things going on during that time. So let's say I asked between 5 o'clock to 6 o'clock in the evening, but during that time they have some activity, so they have not approved the downtime. Now without that database going for shutdown, I cannot shut down the complete container database. So what I can do in such kind of situation? Suppose I have another CDB with the same version. Let's say here I have the version as 12.201 and I have another CDB also with the same version 12.201. Then I can do what I can do, I can move this pluggable database from this container to this container, and then I can perform the activity whatever I want in this container database, and again I can move back the pluggable database to this CDB. So of course moving this pluggable database from one container to another container might take 5 minutes of time, so 5 minutes of downtime. So it's okay, instead of 1 hour giving the downtime, application team may give you 5 minutes downtime. That is okay for them. So that is how the advantage we have. We can move the pluggable databases between multiple container database.
I just have one question. So when you move to a different CDB, correct?
Yeah.
So CDB will have a different data file, right? So
No.
both these CDBs will have different data files, correct?
When we move the within, I mean, here again there are two things. Suppose these two container databases, this container database and this container database are within the same server, let's say, then you don't require the data file movement. But let's say the first CDB in one server and the second CDB is there in another server, then yes, because the mount points and everything will be different, you need to go ahead and even transfer the data files as well.
Okay.
But most of the times, that will not be the case, because if we need to move the data files, then it is equals to downtime again. So that's not the idea. When somebody says moving the pluggable database from one container to another container, mostly it will be within the same server. So that's the reason moving the data files and other files are not required.
But even the metadata and all this stuff. Okay, so when you move the PDB, you mean to say the all the metadata will be moved along with it, right?
No, no. Metadata, that's what I said. Here in the concept, there is no point that we will have metadata in PDB. All your base tables and all will now reside in CDB only.
Yeah, that is correct. So metadata now it is there in CDB1. Let's say all the metadata is there in CDB1. Now you are moving the PDB to CDB2.
Yeah.
So the because the metadata exists in the CDB, how will that metadata will be copied over now? That we'll talk later. I'm just asking whether is this the right time to talk, or we'll talk.
Yeah, it might get cleared at later point of time. Yeah, once
Okay.
we see
Okay.
the things like after I create the database and I show you the
Okay.
reference, then you will understand that.
Okay.
And also, this move in and move out of the pluggable database is helpful during the time of patching as well. Like, I mean, this is the practice even what we are following in our project right now. So what we do is, for example, October patch has been released and we need to apply that October patch. So what we do is, instead of applying that October patch to this container database, because we require a downtime, and of course all the pluggable databases also need to be down. So what we do is, we will create one empty container database of the same version, and we will apply patch on this October 2017 patch. So the version will be latest. Then we will move all these pluggable databases to this container database. So for each pluggable database, there is only 5 to 10 minutes of downtime, and all the pluggables will move to this container database. So this container database will be empty now. Next cycle, what we do is, again January 2018 patch will be released. So during that time, what we do is, to this container database, we will apply Jan 2018 patch, and we will move back all the pluggable databases from second one to first one. Again, for each pluggable, it will take only 5 to 10 minutes of downtime. So earlier, we used it to take almost 1 to 2 hours. In a safe side, we use it to take 1 to 2 hours of downtime from the application team, whereas now we are completing entire activity just in 30 minutes. That to maximum time I am saying. So this is also one of the advantages of having this move in and move out. Like during which time this will be helpful is during the patching time like this. Then separation of data and metadata, of course, more clarity is required. As Sachin asked, there is lot much things that we require to understand, and of course, less downtime during patching and upgrade process. So this is one thing which with respect to the data and metadata things. So normal architecture, what we used to have. So here you can see that normal architecture used to have details of both user data and the base. I mean user data in the sense the regular table as well as the any table created by this user. They both share the same metadata. For example, here if you look at the diagram, we have under obj dollar, here you can see some red lines as well as the gray lines. So red lines represents the database metadata and the gray color lines represent the user data like employees table, departments table and all. This is the one which we used to have till now. But in multi-tenant, it will be like this. So in root, in the sense in the container database, we will have only database metadata like obj dollar, tab dollar, source dollar, and all. And other metadata with respect to the user will have again a user base tables, like which means two sets of base tables will be there now. One set of base tables which contain only user data will be there in the pluggable, and another set of base tables which contain only database metadata will be there in the container database. So because of this reason, whatever you do at pluggable level will not reflect into the root container. So let me take an example here, maybe to make you understand. So I'm just now first explaining about the normal architecture what we have. Suppose I have tab dollar base table. You know it contains the details about the database tables. Let's say I have created one table by the name T1 in some XYZ user. So where the information of this will be stored? Of course, it will be stored in this tab dollar itself. Now I created some table in sys user. Let's say table name is T2, where that information used to store in the same tab dollar table. So this used to be the normal architecture. Now what happened? There will be two sets of base tables. One set will be there in the container database and another set will be there in the pluggable database. So when I create a table in the normal user, Oracle will understand that this is a pluggable database activity and it will store this information in pluggable database tab dollar table. So here I will be having one tab dollar table. So in that Oracle will store this information. And when I create some other table in sys user, it will understand that it will be a database related thing which I need to store in container database. And in this container database tab dollar, it is going to store that information. So usually we will not create any tables in sys user manually, we know that, but this is how it will be done. So whenever you create any sys related objects, it will be updated in container database. Whenever you create any user related objects, it will be there in pluggable database. Now suppose I have, when I say the version of the container databases are same, it means that same number of base tables will be there in this container as well as in this container. So let's say I have two containers, CDB1 and CDB2. So when I say both are having same version, and here if I have 100 base tables, here also I will be having the same 100 base tables. And when you move out this pluggable database from this container to this container, entire pluggable will come as it is, including the base tables of pluggable. And for container, same 100 tables is there in the first container as well as second container. So in that case, the move in and move out will not be a problem, because Oracle, here the container databases are having the same number of tables or same version it is, and your pluggable database is not dependent on the container database metadata, because your pluggable is having its own metadata here. So that is why it is possible to move the pluggable from one container to another container. Does that clarify your question, Sachin?
Yes, Pawan.
Okay. So that is about the metadata storage. And then how the pluggable database can be created. So there are lot many ways to do that. So here you can see, first relocating. As I said, you can relocate from one container to another container. Or second one, you can copy the pluggable database, means you can perform a cloning. Again, cloning can be done in two ways. One is cloning from the seed database. As I said, we have something called PDB$seed. So from that you can perform a cloning, or you can clone a pluggable database, again either in a local machine, within the same machine, or if your database is there in remote machine, from that remote machine also you can perform a cloning. And also you can clone from the existing pluggable database or from a normal architecture database, that is Oracle call it as non-container database architecture. Then we have plugging in. So we can adopt a non-CDB as PDB, or we can plug into a unplugged PDB. Like we have several things here, but most of the time what we do is either a clone, means we have a normal architecture database and we want to convert that into a container database and pluggable database concept. So how we can do that? We have that one, and of course we can use DBCA in order to create a new pluggable or container database. And earlier in 12c release 1, we used to have only one undo table space for entire container database. So which means in one container, if you have 10 pluggable databases, for all the 10 pluggable database, we used to have only one undo table space. And so many users face problem with this. So Oracle has improvised in release 2, and it has introduced individual undo table space for individual pluggable database. Now coming to the types of users, as we have so many, we have a container database, then pluggable database, so many things are there. So there will be basically two types of users here. So one is called as a local user, and other one we call it as a common user. So let's say this is the container database and I have multiple pluggable databases. So if you create a user in one PDB, then that will become a local user. And if you create a user in CDB without more privileges, then that will also be a local user. But if you create a user in CDB with more privileges, when I say more privileges, it means that user will be able to access all the pluggable databases, then we call it as common user. So common user will have the advantage to access all the pluggable databases. And you can create common user only in container database. You cannot create common user in the pluggable database. So it is not possible. And apart from that, to do the administration, like if you want, because each individual pluggable database is different database, so if you want to accommodate different DBAs to these different pluggable databases, we will create a different user like PDB admin, pluggable database administrator. So this user will be there as a local user in each and every pluggable database, and that username and password will be given to the respective DBAs. So DBA who manages, let's say pluggable database 1, will be knowing its own, this PDB admin user and password. Like that, similar way, user 2, pluggable 1, pluggable 2, pluggable 3, all these will have the same things. So that is about the users. And to differentiate between the common user and the local user, generally the common user name will start with C double hash. So if you give any other syntax, any other naming convention, Oracle will not accept this. So it should start with C double hash and then the username. Then Oracle will understand that this is a common user and it will have access to all the pluggable database. Similarly, when it comes to the roles and privileges, again we have this same concept. You have local roles and you have common roles. So when you grant common roles, obviously they will be able to access any pluggable database, and when you grant local roles, they are constrained to only that particular pluggable database. So as I said, from release to 2000 plus pluggable databases can be created. Of course, depends on the server capacity. Then cloning can be done at pluggable level. Means if you want to clone a particular database, one pluggable, you can do that. But whereas patching and upgrade should be done at container level only. You cannot patch one pluggable database or you cannot upgrade one pluggable database. And there are multiple other points which we will see that. And one more important thing is a non-container database means the regular or normal architecture database can be converted into container, but not vice versa. Means if you have a container database concept, you have a container database, you cannot convert that into a normal architecture database. That is not possible. And also there will be only one parameter file and one password file for multi-tenant architecture. So that password file and parameter file will be there only for your container database, and also the alert log. So alert log, then some other files like redo log files and all will be there for the entire container database. You cannot have alert log file individual pluggable database, or you cannot have redo logs for individual pluggable databases. So like that we have the things. So tomorrow we will see how we can create this pluggable database first with the DBCA, then how we can do that manually. So we will see all those things, and we will continue with other topics, how to create the user, how to move the pluggables, and all those things. Anyone having questions?
How many container database can we have in a single server?
That is what, as I said, it depends on the server capacity. Like if you are using a 1 terabyte RAM, and you have something like 128 core CPU, then maybe you can create some 50 or 60 container database and all. I mean, just taking a view like that.
But in real time also we'll create so many container databases, like more than 5 or 10, like that.
Yes, we do. Like like in our environment right now, we are doing the same. So we are creating multiple containers, and in each container, we are again posting multiple pluggables.
But how about in rack? There is a different node 2 and 4 node racks. So
We,
in this
we
container databases, we'll be having different more of, and this performance doesn't make slow here.
Not exactly, and also we can have rack environment here also in the container and pluggable.
Mhm.
So here also you will be having multiple instances. So obviously the performance will not be impacted. So anyway, we will talk more about the performance related things and all, because some more things that we need to be discussed. So gradually when we move on, we will understand about these things. So let's meet tomorrow at the same time, and we'll see the things. So thanks everyone for joining. Have a nice day.